In this video, I want to show you how we can set up a very powerful lighting rig in Blender to help us when sculpting. I said that I wanted to record this video a few months ago, and I haven't done that because there is actually a little issue when it comes to undoing within Blender, and I'll talk more about that later. But I've kept you all waiting long enough for this video to be produced, so here we are. If you're new to my channel, welcome. I've been doing character art professionally for over a decade now, and I worked on some major AAA projects along the way. I've used ZBrush as my go-to sculpting software for most of my career, but I've recently decided to give Blender a try, and I've figured out that I actually really love to sculpt within Blender. And a big part of that is because of Blender's lighting and rendering capabilities. What I really want to focus on today is how can we set up a really awesome lighting rig within Blender to really help us properly judge the volumes of whatever it is that we are sculpting on. We are going to talk about lighting, we are going to talk about cameras, we are going to talk about the David's anus. And I'll show you a few neat camera tricks that we can use to leverage the fact that we can have multiple active viewpoints on our 3D model. Things are going to get a little bit technical, but before we go there, let me show you the example scene that I have prepared for the occasion. Here's the head that we'll use as an example, which is a freestyle mix of Ed Harris, Rutger Hauer, and Clint Eastwood. On the top right of Blender's main 3D viewport, I can switch over from solid preview rendering mode, which is often the mode in which you will be in when starting within Blender, to a much better rendering mode, which includes key lights within the scene and an HDR for some ambient lighting, to the last rendering mode, which still has the key lights that I have placed within the scene, but with no more ambient light, giving us this beautiful chiaroscuro lighting. I currently have two key lights within my scene, which I can select and move around by pressing G. These key lights that are within the scene are set to always stay at a specific distance from the 3D model. So even as I rotate them around, the intensity of the light does not actually change. I can choose for these key lights to either be stationary within the scene, as they are right now. You can see that they are lighting the front of the character, but they are not lighting the back of the character. Or I can choose to have these lights follow the camera around as I spin around the model, as you can see right here. And we can choose to sculpt on our model using whichever rendering style that we prefer. I find this very useful because sometimes I know exactly how I want to light a particular 3D model, and I want to be able to work on the 3D model under that particular lighting. So let's say that I want a very dramatic lighting with the light coming from the top of the character. I can go ahead and do that, place my lights, go back within sculpt mode, and I can continue to sculpt on my character, all the while paying attention to how the light and the shadows are sculpting the volumes. At the bottom of my Blender interface is a timeline that I can scrub through to rotate my lights around the scene. And this works just as well regardless of whether my lights are set to be stationary or if they are set to follow the camera around. You can see in Blender's outliner that I have a few cameras within the scene, and I keep these cameras active in a separate Blender window that is on my secondary monitor. These provide very useful real-time feedback for me because it means that I can see what my model will look like under different angles or under different zooms. The camera that I have that is named Distance Lock is set to always have the same orientation as my main camera within the scene, but it is set to always stay at a specific distance from the 3D model, as you can see. This is very useful if I want to zoom in on a very specific zone of the model, such as the nose in this particular case, but I want to retain the ability to see the impact of the changes that I am sculpting on the whole head. And the cameras named left and right within the scene allow me to simply have a different point of view, a different angle on the part of the 3D model that I am currently working on. So for example here, I'm zooming in on the nose within my main 3D window. And you can see that on these left and right cameras, I can see the nose from a 90-degree angle. This means that if I want to add a little bit of volume to the tip of the nose, I can do that within the main camera, which is facing the model straight on. And I can use those left and right cameras to see how far forward am I pushing the nose in the process. These cameras don't need to be set at 90 degrees necessarily. I can change that angle as much as I want. But here's an example where this is very useful. Let's say that I want to add a little bit of mass to the fat pads that are in the mid tier of the face right here. I can very precisely add a little bit of volume here to the cheeks of the character. And while I'm doing that, I am keeping an eye out to see how much are those changes impacting the silhouette of the model. So this is a great way of getting that feedback. While it takes time to do this particular camera and lighting setup within our scene, the result of our hard work is a scene where we can have a very accurate representation of the volumes that we are sculpting, which in turn helps us to work a lot faster. So how do we set up a scene this way? Let's go through it step by step. But before we do that, I just want to say that if you want to grab this scene for yourself and you want to skip the whole setup yourself, you can actually grab this file by becoming a member on Outgang.studio, because I am distributing this particular work file, including the head that is in there, to all Outgang members. So if you're a member of Outgang.studio, you can go to the handouts page of Outgang, and there you will see all of the handouts that are available to you, including this particular scene. So you can skip the whole setup yourself. You can just grab the scene, replace the head that is in there with your own, and your lighting and camera rig will be fully set up. And your Outgang membership comes with a whole host of other features, such as ZBrush masterclasses, Blender masterclasses, Marvelous Designer masterclasses, and a whole host of handouts to help you become a better character artist. And as a special deal, choose the monthly plan and use the code Outgang2023 at checkout to get 50% off for your first month. This code is only valid for 100 uses, so register soon. Okay, so let's go through this step by step and see how we can set this up ourselves. I'm starting from a default Blender scene, and the only thing I have done in here is to get rid of the default cube and instead import my head in there. Within our default scene, we already have a default light that is in there, which we could move around, but I'm just going to go ahead and I'm just going to delete that for now. And instead, let's add 2 key lights within the scene so that we can already start playing around with those. So I'm going to go to Add, and we're going to go to Light, and let's add an area light within the scene. And we can press G to move the light around. We can press R to rotate it so that it is facing the model. If we switch over to the Material Preview Viewport Shading, we'll be able afterward to click on this little drop-down arrow that is right here and say that we want to light using the scene lights. And at the same time, let me take the strength of the HDR, which is by default within the scene, and just reduce it down to 0. Then I can go within the light properties by clicking on the little light bulb icon that is right here. And we can reduce the size of it because 1 meter is way too large. We're starting to get a more interesting lighting going on in here. We are going to tweak the field of view on our camera because right now there's a little bit too much camera distortion within the scene. So within our right menu that is right here, and if you do not see this within your own scene, you can press N to open and close this particular menu that is right here. let's go to View, and in here we will increase the focal length of the default camera. And I will duplicate this particular key light by pressing Shift D. While I'm here, let me add 2 empties to this scene, and I'll explain later the reasons why we are adding those within the scene. Let's go to Add, let's go to Empty. Let's just go for the default one of plain axis right here. With my empty that is selected, let me just go within its object data properties, and we'll just set the size here to be 1 centimeter. I'm gonna call this first empty rig_center. And then I'm gonna add another empty to this scene, and I'm gonna call this one turntable. I'm gonna parent the turntable under my rig center by holding down Shift and doing a left click and drag from turntable over to rig center. And I'm also going to make my lights a child of this turntable empty by doing the same thing. This makes it so that our lights are the children of our turntable, and our turntable is a child of our rig center. Let's select our lights and simply make sure that they are casting shadows. Let's go to our Render Properties tab within Blender and make sure that the render engine that is selected is right now set to Eevee. Then let's go within our shadow settings and set the cube size here to something bigger than the default 512 pixels here. And while we're there, why not turn on here hide bit depth? Then let's go to screen space reflections. Let's turn that on. Let's disable half res trace as long as your video card is able to support it, and increase the trace precision over to 1. Screen space reflections just give you slightly better specular highlights within the scene. Then we can go back and tweak our shadow settings on our lights. So I'm going to turn off here the second key light that I have added within the scene, just so that we can see the impact of playing around with the shadow properties on one of our lights. Then I'm going to select the first key light that I have set within the scene. Go within the object data properties for that particular light, and within shadow then we can play with these settings here. As I turn on contact shadows, we are getting much more accurate shadows within the scene. To make them even better, let's take the bias value here under contact shadows and set this down to its lowest possible value. And finally, take the distance value that is here and just set it to a value that is much longer than what is the distance between your light and the middle of your scene right now. So I'm going to go ahead and set this to 10 meters just for the sake of it. And as I rotate around the scene, you can see how our shadows are now of a much higher quality for our first key light that we have. Let's do the same thing on our second light. One thing you might already notice is that our shadows have a tendency to flicker a little bit as we rotate around the scene. And if we sculpt on our 3D model, we'll see that the same thing actually happens. This flickering comes from the fact that our lights are area lights, so they have a particular size within the scene. So the shadows that they cast are not harsh shadows. They have a little bit of a gradient to them. In fact, if I take one of these lights and I play around with the size of that particular light, you'll see that our shadows will have a tendency to become a lot softer. This is great for final rendering, but if it bothers you that there is that flickering that is happening, then we can actually make it so that our lights always cast a harsh shadow. And to do that, it's very simple. Let's go back to our render properties. Let's go within shadows yet again, and let's turn off soft shadows. But we can still play around with the size of the area light, which has the effect of diffusing a little bit more the specular highlights the bigger is the area light. So this lighting is already getting pretty interesting for sculpting. But as we are sculpting, we will definitely want to move the lights around the scene from time to time. So if I go ahead and grab one of my lights that I have in here, and I press G to move it around, you can see that as I move it around, the light does not necessarily always orient itself towards the model directly. And if I move the light too close to the surface of my model, our lights will become way overexposed. So it would be best if we could constrain these lights so that they are, one, always facing towards the model, and second of all, if they could stay at a consistent distance from the 3D model so that the intensity of the light is always the same, no matter where they are within the scene. With my first key light that is within the scene and that is selected then, we're going to go ahead here and switch over to the Object Constraint Properties tab of Blender. We're going to go ahead here and add a track to constraint. And then we are going to select as the target for that our rig center. This will make it so that no matter where this light is within the scene, it will always be oriented towards the center of our rig. And then we're going to add a limit distance constraint to our light. We will once again here select our rig center as the target for that. We're going to set the clamp region over to on surface. The distance value that we now have within our constraint specify the distance from the light to the center of our rig. Then I can go within the object data properties for that light, and I can adjust the power of that light to be whatever power it needs to be so that the model looks well lit. And now if I press G to move the light around, the light will always stay at a consistent distance from our 3D model. So we want to do the same thing for our second key light, and of course the simplest thing at this point is simply to erase it and do a Shift D on our first key light to duplicate it with its constraint. And of course, no one says that your two lights have to be the same distance or the same intensity from your 3D model. It is up to you to make that choice. Feel free to also add a few more lights within the scene if you want to. You could add a few ambient lights within the scene, for example. Although what I like to do to get a little bit of ambient lighting in here is to play with the HDR values that are already set within Blender's viewport. So we can access our viewport shading options once again by clicking on the little arrow here that points down. I'm just going to increase the strength here a little bit, and as you can see, as I'm doing so, I'm adding some ambient light to this particular scene. We can, of course, rotate this HDR around. We can expose it so that it is part of the background by playing here with the world opacity and playing around with the blur values that are right here if we want to see what the HDR actually looks like. And we can, of course, switch this HDR to whichever comes by default within Blender. So feel free to play around with the intensity of your lights, the intensity of your HDR lighting to get the perfect blend that you are looking for. If I go and render it here and I turn off Scene World, then I have the same control over the HDR within the scene. But one thing that I particularly like to do myself is to turn on Scene World here for our rendered viewport shading style. And then afterward, to go within World Properties, and where it says color in here, taking the color and putting it to be completely black. So within my Material Preview Viewport Shading mode, I keep the Scene World checkbox turned off so that in this particular viewport shading style, I can play with the strength of my HDR to have a little bit of it or a lot of it within the scene. And I switch over to the rendered viewport shading style when I want to have those dramatic dark shadows in here. And of course, we can always go back to our solid rendering mode if we want to see what our model looks like with the default rendering mode of Blender. So even though this setup so far is still relatively basic, we can definitely take advantage of it by going within Sculpt mode of Blender. And you can see as I sculpt around, you can see that we can really take advantage of Blender's very nice shadows when it comes to sculpting to be able to accurately judge what it is that we are doing. But as I said, we can also set these lights up on a turntable so that we can rotate them easily around the scene. So let's go ahead and do that. Go ahead and do a click and drag on the lower left corner of your main Blender viewport. We can switch over the editor type over to the timeline editor so that we can see the timeline that is displayed for us. What we're going to do now is to add a series of keyframes to our turntable empty that we have added within the scene. Let's go down here to frame 0 to begin with. And then with our turntable empty that is selected, let's press I to insert keyframes, and let's insert rotation keyframe on this turntable at frame 0. Then let's scrub through our timeline to the last frame that we have. Let's turn on auto key. Let's go within our item properties And where it says rotation then, let's set the Z rotation over to 720 degrees. And now if I scrub through the timeline, you can see that our turntable correctly spins around. Let's just turn off auto keys so that we don't accidentally add more keys to this timeline. Then let's switch the editor type over to the graph editor. And within our graph editor here, I'm gonna hold Control and do a middle mouse click on my mouse to be able to zoom horizontally and vertically until all the keyframes fit. Then I can either do a click and drag to select all of the keyframes that are there, or what I could have done from the beginning is just to press A to select all keyframes. Let's do a right click afterward. Let's go to interpolation mode and let's set the interpolation here to linear. As a consequence, as I scrub the timeline here, you can see that our turntable is spinning around at a constant rate. I can switch this editor here back over to the timeline, and I can then minimize the timeline here so that it takes the least amount of space at the bottom of my Blender window. So our turntable now works, and for all intents and purposes, this is already very, very good. We definitely have a lot of options at our disposal to do some sculpting now with some really high quality lighting, but our lights do not currently follow the camera around as the camera moves around the scene. So let's talk about all that. In order to set up our light rig to follow the camera around, we need to be able to read what is the position of the camera through which we are working. And right now, even though I do have a camera that is there by default within the scene, we are actually looking at the world through the user perspective. And you can see that on the top left of Blender's interface. We can switch over to see the world through the camera that we have within the scene by pressing 0 on our numpad. And then in the right pane of Blender, I'm gonna switch over here to View, and I'm going to turn on View Lock Camera to View. This will make it so that we will be piloting through the Blender scene, as you can see, while always looking through our camera that we have by default within Blender. If you want to get rid of the darker frame that you can see right here within our viewport, we're going to press Home to zoom in so that we are seeing through the camera. I can go afterward within its properties right here, and I can play around here with the focal length. So if I want to change the default value here of 50 millimeters, I can do that, and I can set this to whatever value I want it to be. It is very simple to set up our light rig so that it follows this camera around as we rotate around our 3D model. We're just going to select our rig center empty that we have. Then we're going to go within its constraints, and we're going to add a locked track constraint to it. Then we're going to select the camera as the target for that. So it says target here, select camera. And the result of all that is that as you spin around the scene now, as you can see, our lights follow the camera around. Best of all, our turntable still works. So we can still rotate our lights around the scene using our turntable, get a particular lighting angle that we like, and as we rotate the camera around, our lights now follow the camera as well. This is great because it gives us the impression that it is not the camera that is moving around the scene, but rather it is the 3D model that is spinning around. And I think this might be more intuitive for some of you when it comes to sculpting. We can work just as well on our model when we are looking at the world through this particular camera. But there is an important caveat here, and it is very important that you understand it. Because this camera is now an object that exists within the scene. So if I pan the camera around here and I do Control Z, you'll see that we are going to actually undo the movement of the camera. It's bad because perhaps you are sculpting on your 3D model, like so here. I'm just going to sculpt some very, very ugly wrinkles in this particular case. And then perhaps I want to rotate around, maybe zoom in a little bit, and then maybe I want to work on some of these other wrinkles that are here. And now the problem is that if I do Control Z, I'm not going to undo only the brush strokes that I have done, but I will also undo at the same time the movements of the camera, as you can see. We don't necessarily want to undo the movements of the camera when we are sculpting on a head, we just want to undo the brush strokes that we are doing. And this all comes from the fact that there is no way to hook up our light rig to follow around the user perspective And I've actually looked online to see if there was a solution to that. And unfortunately, I found no way to access some type of read-only variables for the user perspective camera.
Welcome to Intermission.
So I said that I had a few workarounds for you, and these are what the workarounds are for this particular problem. You can decide, for example, to live life on the edge by going to Edit, Preferences, going to System afterward, and setting your undo steps here down to 0. By doing this, you're not going to have to worry about the camera movements polluting your undo history because you're not going to have any to begin with. You'll be forced to commit to every brush stroke that you put down on the model. That's hardcore, man. But what, you think Michelangelo had access to undos while he was sculpting the David? I understand now why Michelangelo decided not to sculpt the David's anus.
A quick inspection of his back half reveals he doesn't have an anus. It's a baffling omission.
One wrong chisel stroke there, and historians throughout the centuries would have had to conclude that the David had hemorrhoids. Not a legacy you want to leave behind. So anyway, we could go the other way, and instead of setting our undo limit down to 0, we could actually set it to its maximum value of 256. And like that, we'll still have to deal with the fact that our camera movements will pollute our undo history. But at the very least, we will have so many undo steps that it shouldn't be too bad, and we should still be able to undo all the brushstrokes that we are adding on top of our model.
All those
Brushstrokes
will be lost like tears in rain.
Of course, another workaround is that you can try to move the camera a little bit less and not frantically move the camera around between every brush stroke as I have a tendency to do. So don't work like me. And finally, another option that you have at your disposal as a workaround is to turn off the global undo checkbox that is right here.
What the hell are you doing? Have you lost your mind?
What will happen now is that as you sculpt around, even though I am sculpting, adding a few brush strokes, and moving the camera around, when I do Ctrl Z, I will only be undoing the brush strokes. So disabling global undo seems to work pretty well, but there are other side effects. I've seen things like moving some objects around and then doing Ctrl Z to undo the movement of those particular objects, and the objects never actually getting back to where I wanted them to be originally. I've seen odd behaviors like that I've had a little bit of a hard time to explain myself. So there you go. Those are all the workarounds. None of them are perfect. So, as we say, choose your poison. And if at some point the Blender team can make it so that we have access to the position and orientation of the user perspective, we could actually fix this so that we are orienting our light rig to always point toward that user perspective. All the other features that we'll talk about today are related to camera setup and having secondary cameras follow the primary camera of Blender around. So the same thing applies. Let's create then our camera that will be distance locked to a certain distance from our 3D model, which will be very useful for us if within our main camera of Blender, we want to zoom in very close to the face, but we want to always retain the ability to see the model at a certain distance. What I'm going to do then is that I'm going to open a separate Blender window that I will put on my secondary monitor. And we will do that by going to View, going to Area, and afterward doing Duplicate Area into New Window, which I can take and I can move over to my secondary screen. Then let's take the default camera that we have within Blender, and I'm going to do Ctrl C and Ctrl V to copy paste it within the scene. We're going to rename this one to camera_distance lock. And we're going to set this camera to be the active camera of our duplicated Blender window. So on my secondary monitor here, which right now effectively shows me a duplicate of my main Blender window, we are going to go within our right tab, within View. And in here, you can see that there is an option here called Local Camera. So I'm going to go ahead and check this little box that is right here. And afterward, I'm going to click where it says camera, and we're going to select camera distance lock. Then I'm going to go back to my main Blender window. I'm going to get out here of camera view and back within user perspective view, just so that we can see a little bit easier what we are doing. Let's select then our camera distance lock, and we need to add 3 constraints to it, with the first being a child of constraint, and where we specify the target to be the main camera within the scene. This effectively makes it so that if I select here the main camera of the viewport and I move it around, you can see that the distance locked camera follows it exactly. The second constraint that we will add is a track to constraint. And within this track to constraint, we will specify that the target is the rig center. And this simply makes it so that our distance locked camera is always aimed towards our 3D model. And finally, we want to add a limit distance constraint to this camera. We'll also specify that the target here is our rig center. We'll say clamp region on surface. And now the distance value that we have will simply control how close or how far our camera will be from our 3D model. You'll see that as I play around with this limit distance value, I'm effectively moving the camera closer or further from my 3D model. And now within the main viewport of Blender, if I go back to my main camera in here, as I move this camera around and I zoom in on the model, you can see that on my secondary monitor, I am always keeping the same point of view of the model, but my camera is always set to be at a specific distance from the model. As we said, this is very useful if I'm zoomed in very closely on the part of my model and I am sculpting on it, but I want to retain the ability to see the impact on the larger shapes of the 3D model for the changes that I am doing. And of course, this secondary camera can have its own rendering mode that is set as well. Now, I've told you that we can also set up our cameras to have an angle difference with the main camera, which can help us sometimes when we are sculpting directly on the surface of the model, but we want to see the impact of what we are sculpting on the silhouette of a model. And perhaps this sounds like it would be complicated to set up, but it's actually very simple because I can already go within my secondary window that is here. And because I have the camera to view lock button that is turned on here, I can actually rotate in here my viewpoint around. And as I rotate the main camera around, you can see that the side camera keeps on rotating with the same angle offset. So I'm going to go ahead here and take my camera distance lock. And once again here, I'm just going to duplicate it. And I can get rid of the camera.001 that was added because that was a dependency, but we don't want to keep that. And our camera distance lock.001, let's take that here. Let's rename it here to camera offset. And I'm going to set this camera offset to be the active camera within my secondary Blender window. I'll just relink all of the constraints of this camera offset the way that we had them before. And at the same time, let me delete the rig center.001 that got added. You can see now, if I zoom in here on my main Blender window, our secondary camera now, our camera offset, stays obviously at the same distance from the 3D model. And that's because of the limit distance, of course, that we have created as a constraint there. But we don't necessarily want to get rid of that, but we want to repurpose that so that the limit distance actually sets the distance of the camera to the rig center. So the way we're going to do this is by right-clicking here where it says distance. And we are going to add a driver to this. Now, this gets fairly technical, okay? I do want to apologize for that. But if you follow along, you should be fine. Then I'm going to right-click on this again, and we're going to open the drivers editor. Where it says expression here, I'm just going to get rid of the number part and the plus part so that it is only a variable here, or var that is, set as the expression. Then, where there's a little x here within parentheses, I'm going to click on that, and we are going to set this here to distance. And the distance that we will specify here will be the distance between our main camera and our rig center. We can now close this, and as a consequence, as I zoom in and out, as you can see, of my main Blender window, my secondary camera is also zooming in and out. And finally, just to be extra cute, one other constraint that we can add to this will be a copy location constraint. And we will set the target of this copy location to be our main camera, and we will only want to copy the Z axis. Let's take this particular copy location and let's move it under our child hub. And as a consequence, this will just make it so that if my main camera here rotates here towards the bottom so that we are looking up at our model. Our secondary camera will follow that a little bit better than what we had before. So now, if I put my main camera to look straight on the model, and within my secondary viewport, if I go ahead and spin it around so that I'm looking at the model here from 90 degrees in relation to my main camera, you can see now that as I move my main camera around, I am always looking at the model with that 90-degree offset within my secondary camera or my secondary screen. Now this works great until you want to start to zoom in and work on very specific features. So while we're working on the head as a whole, this whole setup here works really, really well. But as you can see, the moment that I want to zoom in and work on, let's say, the tip of the nose, as I have shown you earlier within the video, I'm now actually zoomed into the ear, so this makes no sense. It is impossible to work with this. And so the solution to this is something that we have been building and working with since the beginning of this particular video, which is our rig center empty.
Sounds like you reached the center of the maze, my friend.
You see, if I take the rig center that is right here and I move it somewhere else, this will be the point of focus of all of our cameras and our light rig combined. So for example, if I take my rig center that is right here and I move it so that it is on the tip of the nose, you can see what is now happening on my camera offset. I'm still looking at the nose with a 90-degree offset within that secondary camera. And actually, let me just go within its camera properties. Now that I see this, let's go within its camera properties. And let's say its clip start here to be 0.01. And as you can see, as I'm looking at the tip of the nose and I am zoomed into the tip of the nose, my offset camera is looking at the tip of the nose with a 90-degree angle on the right side. So this is the purpose of that rig center empty that we have been setting as the target since the beginning of this particular video. Now it can be a little bit bothersome to always have to take the actual empty and move it directly by pressing G. But one thing we can easily do now is to take advantage of the 3D cursor of Blender and snap our rig center to our 3D cursor. So for example, let's say that I want to work on the ear that is right here. What I can do then is to hold Shift and do a right click somewhere on the ear. So let's say right here on the counter helix, so that I move my 3D cursor over to that part of the model. Afterward, select my rig center empty, do Shift S on my keyboard and select selection to cursor, which will effectively snap my rig center to the ear. And now, as you can see, in my main camera of Blender, I can zoom in on the ear. I can look at the ear from very, very close. In my other camera with the angle offset is also pointing at the same target. I can reset, of course, the position of my rig center by taking it and putting its location values back down to 0. And then finally, of course, I can take my secondary screen, I can split it in two and set the left area here to be using my camera distance lock and keep my camera offset on my right area. So again, if I want to work on, let's say, the tip of the nose, I can hold Shift, do a right click on the tip of the nose. Afterward, take my rig center, press Shift S, selection to cursor. So I can now work on the tip of my nose within my main Blender window. And on my secondary screen, then I have one camera that is set up so that I can always look at the head in its entirety, and I have a second area that is set up to look at the tip of the nose with an angle offset. Finally, in those secondary cameras, we can actually turn off here the gray borders that we have on the top and on the bottom by selecting those cameras, going within their properties, and within the viewport display here by simply turning off here where it says Passe-Partout. And of course, because now the aspect ratio of these areas is a little bit different than what we had set up before, I can always take, let's say, my camera distance lock and adjust its distance so that I am a little bit more zoomed in to the model. So there you go. It's up to you now to be creative and to set up your cameras the way that you think it would be beneficial for you. But once again, if you want to use this particular scene, you can actually download that particular file that I am distributing to all Outgang members on Outgang.studio. Thanks for watching this video. I'll see you next time. I understand now why Michelangelo decided not to sculpt David's anus.